H2O, CO2, NO2. What are we talking about? These are chemical expressions. In chemistry, a lot of times we don't use the compound name. Instead, we use what we call the chemical expression or formula. Let's take, for example, water. Okay, if we're talking about water, we're setting up a chemical reaction, we might even write an equation and we might use H2O. We know that as water. So if we take a look, H2O, it's saying that we're using hydrogen and oxygen. We see that represented by the element symbols. We also see a little 2 in there. That's known as a subscript, so under the writing. And if you look, it's after the H. So if it's after an element, it tells us how many of the element we have. In this case, we have 2 atoms of hydrogen, and you don't see any subscripts after the oxygen. And why? Because there's only 1. So if you see nothing written there, we assume that there's 1 there. So 2 parts hydrogen, 1 part oxygen. Now you're going to see later on that if we use water in a, say, a chemical reaction, we might even put a coefficient. That's a number that goes before the molecule. Say 3H2O. That's saying we have 3 molecules of water. Or in essence, what we're saying is if I had a bucket with 3H2O in it, we're saying that there's 6 hydrogen and 3 oxygen, right? Because there's 3 H2s and there's 3 oxygen. Okay, so take a look next time you see a chemical formula. Is there a coefficient? Are there any subscripts? Okay, and it does get a little bit more complicated than that. Sometimes you might even see parentheses. Why? Well, that actually helps us with the shape. If we see parentheses, we know what we're looking at as a formula for the structure. Take, for example, isobutane. You might know butane as maybe that little canister we hook up to the camping stove. It helps produce the fuel that might get the campfire started. So if you take a look, CH3, that's inside the parentheses, we see a little 3 subscript outside the parentheses. It says CH afterwards. What they're saying is anything in that parentheses, there's 3 of it. So that's kind of showing you in the structure that's set apart. In reality, we could rewrite that in what's called the empirical formula or the molecular formula. So we'd rewrite this so that little 3 would go back in to going C3H, instead of H3, we have 3 of those, it'd be H9, and then what's left over outside the parentheses, the CH. Now we can actually make that even smaller, we can combine them, and that would make it C4H10. Hopefully you see where we're getting these numbers from. Now, again, there's different ways to write it, so when we're kind of looking at formulas, we're looking at compounds online, you might see it written a couple different ways, and it's really looking at the format of how we're writing these. Now, if you want some more information, you want to check out some other cool compounds, definitely check out Titin. It's Titin. It's pretty neat. If you take a look, there's even Mr. Beast. He goes on for 2 hours trying to read it. It's also known as the longest word in the English language because it is pages and pages long. The other guy, I think it takes about 3 hours to read it. So check it out, pretty neat. Hopefully this is a great guide to understanding how chemical formulas and expressions work.